Right, so we should be live. Yes, we have the sound and everything. Don't have any professional lights or a camera, so that small image is as good as it gets. Hopefully my voice. Hopefully I still have my voice. That's also not a given. Give me a sec. Hit my link live. Right. It says my stream is in excellent condition. That's good to know. I'm also on Zoom and what's it called? I always forget. Discord. Just in case you want to join live. Let's pop it in the chat. My Discord to share the stream. Hopefully this won't be as long as last one. Last night we had like 3 hours trying to troubleshoot the ECG game. Hopefully this one would not be as painful. Hopefully it goes smoothly. I want to pause this quickly. Just give me a sec. So we uh, we uploaded some files to Code Interpreter, GPT-4. By the way, not sure if I'm a bit on the fence if I should continue paying for it or not. So yesterday I changed my subscription status several times, but as it stands, I would not continue paying for the GPT-4, but not for the Plus version, but I'll just pay for API keys. So I have some tokens there. I want to play around with it. I could make a video on it as well. That will show how to limit how much you spend and things like that. Hopefully, yeah, I don't know if the sound of the browser going into the stream as well. Hopefully not, but might fix it later. So we have this to file. Yeah, so I need improvements.
Alright, let's start by taking a look at the content of game_logic.py to understand the current state of the game's logic. After reviewing it, I can then provide suggestions for improvements. Finished working. Show work. From the provided content of game_logic.py, here's a summary of the game's logic. The game uses the Pygame library. The game's objective is for players to find abnormal ECG patterns and avoid clicking on normal ECGs. The game window's dimensions are for width and 600 for height. A waveform is generated using the generate_full_waveform function, and this waveform moves from right to left across the screen. As the player identifies and clicks on abnormal ECG patterns, they earn points. Clicking on a normal ECG pattern deducts points. The scrolling speed of the waveform increases as the score increases. Abnormal waveform segments are inserted at random based on the random number generated and the thresholds defined. The player's score is displayed on the screen, and the areas they clicked are marked with green circles. Now that we understand the basic logic of the game, please specify the improvements you'd like to make or any issues you'd like to address. Waveform equals generate_full_waveform t for t in t_values score scroll_speed tagged remainder equals 0 2 waveform_types equals 0 asterisk with hashtag start with all normal waveform equals generate_full_waveform t for t in t_values score scroll_speed tagged remainder equals 0 2 waveform_types equals.
Where is it reading from? So no, the waveform is not always. So let's start from the files. So hopefully it still has them. I think the problem is now we're plotting the random number itself. When it's below 0.5, we should have an abnormal ECG, which we do not. I don't know what's up with that. So trying to fix that. So it seems like multiple normal ECG waveforms are being generated in the beginning. There is definitely too many of them. The ratios seem correct, and the random number generator seem to be producing good numbers. So just go with that, see what it says. The problem essentially is that we're getting too many normal ECGs. So we need to check that.
If you're observing an excess of normal ECG waveforms at the beginning of the game, it might be due to the way the game starts and initializes the waveforms. From the provided game logic. The game initializes with a full screen of normal waveforms, seg_types is filled with zeros, indicating normal waveforms. This makes the initial game screen filled with normal waveforms. Only after this initial setup does the random number generator come into play to determine the type of waveforms that should be appended as the game progresses. There are a few ways to address this. Reduce the initial waveform. Instead of filling the entire screen width with normal waveforms, you could initialize with a smaller segment of normal waveforms, allowing abnormal waveforms to appear sooner. Introduce abnormal waveforms sooner. Modify the logic so that after the initial segment of normal waveforms, abnormal waveforms have a higher probability of appearing for a short duration. Mix normal and abnormal waveforms. Instead of starting entirely with normal waveforms, you could mix in some abnormal waveforms in the initial setup. Let me know which approach you'd like to take or if you have another idea in mind.
Yeah, mixing is what we want. Let's see, where's that if first waveform? There's a problem in the beginning of the game. And this edge generate multiple waveforms. 0. Now this logic is wrong. Okay, can you explain? Wanna print out the seg length or length of seg. Can generate code to print out the length of variable called seg. What's it seg? Yeah, I want to print this out because this length is too, yeah, the logic there is not quite right. Yeah, I want to print this out of here somewhere. Yeah, that's just wrong. That's very wrong. The length of seg. Let's see if it picks up on it by itself.
The length of seg being 2400 suggests that each generated waveform segment consists of 2400 data points. This length is likely determined by the size of t underscore values, or the resolution of the waveform, and the functions used to generate the waveform. With this information in mind, if the length is as expected, then there's no issue here. If the length seems too long or short for your game's display or mechanics, you might consider adjusting the resolution or the method of waveform generation. For context, in a typical ECG waveform displayed on a screen, the length of 2400 might represent a significant portion of the screen width, depending on how you're rendering it. If this is causing the game to start with too many normal waveforms, you might consider reducing the segments underscore to underscore generate during initialization or adjusting the resolution of t underscore values. Do you want to make any adjustments based on this information, or is there something specific you'd like to address next?
Yeah, there's it. So segment types. Oh, come on, this logic is just, it's quite convoluted. But essentially, yes, the problem is that there's too many normal ECG waveforms are being generated. That's suggesting too many things. Yes, there's essentially too many normal waveforms being generated, and the length of seg seem to be excessive. This logic is also not great, but we'll keep it as that.
If the length of seg is excessive and results in too many normal waveforms being generated, we need to adjust the logic to produce shorter segments or reduce the number of normal waveform segments during the game's initialization. Here are a few steps we can take to address the issue. Adjust the resolution of t underscore values. If t underscore values determines the length of the waveform segment, you can consider using a subset of it or reduce its resolution. For example, if t underscore values contains time values from 0 to 2.4 seconds, given 2400 data points, you might consider using a smaller range. Reduce segments underscore to underscore generate during initialization. Currently, during the game's
So each segment, each waveform should just have one segment type. Does each ECG waveform has one segment type? Let's check that.
Based on the provided game logic, it appears that each generated waveform segment has a single segment type, either normal, represented by 0, or abnormal, represented by 1. The segment type is determined by the seg underscore types list, which is filled with either. Stop generating.
Hello, Rohan. We have Rohan joining in. For the segment, there should be one. Did it say one? Yeah, it should be normal represented by 0. Yes, segment type, segment list, which is filled with either zeros or ones.
Code interpreter. Here, if the segment is a normal waveform, seg_types is filled with zeros. If the segment is an abnormal waveform, seg_types is filled with ones. So, to answer your question, yes, in the current game logic, each ECG waveform segment has a single type, either normal or one of the specified abnormal types.
Doesn't make any sense. Yeah, this logic is no good. It seems that segment types should just have one value. So there is a segment type for the entire waveform.
I see what you're getting at. If you want a single value to represent the type for the entire waveform segment, rather than a list of repeated values, then the logic does need some adjustments. Here's how you can modify the code. Instead of using seg_types equals 0, *len, seg, or seg_types equals 1, *len, seg, you can simply use a single integer value, 0 or 1, to represent the segment type. When appending to the waveform_types, you should append the single value multiple times based on the length of seg. When appending to the waveform_types, you should append the single value multiple times based on the length of seg. Here's a modified version of the first _waveform section. When appending to the waveform_types, you should append the single value multiple times based on the length of seg. Here's a modified version of the first _waveform section to incorporate this change.
Okay, that doesn't make any sense.
With this modification, each segment of the waveform will have a consistent type, represented by a single integer value, either 0 for normal or 1 for abnormal. This should simplify the logic and make it more intuitive. You can integrate this modified logic into your game loop. Let me know if this is what you had in mind or if further adjustments are required.
We have segment. How many types? Type. Do we have waveform? Yeah, we have. No, we have event type. Do we have waveform? We need just a waveform type. I don't understand why it's plural. It should be. Yeah, the whole logic of is incorrect. We should just have one type for a whole waveform. So each waveform should have just one indicator number, 0 or 1 for normal and abnormal waveforms. Again, waveform types variable should not have multiple numbers in it. Should just have one value.
You want the waveform underscore types variable to only contain a single indicator for each entire waveform, rather than individual data points. The logic can be simplified further. Let's break this down. Each time a new waveform segment, either normal or abnormal, is generated, a single indicator, 0 for normal and 1 for abnormal, should be added to waveform underscore types. The waveform itself, waveform variable, will contain multiple data points, but its type, in waveform underscore types, will be represented by just one value. Here's how you can implement this logic.
Yeah, this would be risky, but can you rewrite this whole code with the updated changes? It got way too complicated.
Absolutely. I'll update the code to ensure each entire waveform has a single indicator for its type. This means that waveform underscore types will just have 1, 0, or 1 for each full waveform, rather than a value for each point in the waveform. Here's the updated game logic based on the changes discussed.
And so again, I don't quite get it. It's using Python to essentially generate the text. I mean, it's not doing it in this Python code. It's all commented out. No, it's the code. Don't know why it's in that color. Keeps generating. I don't know why it's just not generating it in text. Make a copy of this game logic so we don't lose it. But yes, I can't see how it can make it worse. I mean, everything is possible, isn't it? It could be worse. Right, so it's kind of weird how it works, the code interpreter. So it's trying to essentially execute this code in Python, even though I ask it multiple times, no, just once, but normally ask it not to do so. Yeah, and then it's just generating. Yeah, apologies for what interruption. Here's the updated code, and just need to make sure it's the same code without any significant changes. Yeah, these two obviously be the same for now. Just made a copy of it. Yeah, displaying current score, and this should be it. Yeah, so waveform types should just now contain just one number.
In this updated logic, I've adjusted the waveform underscore types variable so it contains just one value, 0 or 1, for each full waveform, representing its type, normal or abnormal. This makes the game logic more streamlined and easier to understand. You can replace your existing game logic with this updated version and test it on your.
Yep, test it on my machine. That's right. I don't know if it's removed the. Normally, when I ask it to do this, it will remove the debugging printouts. No, and it didn't remove them in this case. We can the print find print. No, we want to keep this print. Yeah, I want to get rid of that print. We want to make sure. Oops. Uh, yeah, let's just print abnormal types. The whole value probably be printed too many times. Wait a second. Okay, this is wrong. Wait, actually, wait, now I'm confused. We had segment types. Now we have seg type, just singular, just good. Seg type 0. To understand why is it printed so many times. Yeah, this still. So seg type 0 is normal, 1 is abnormal. And we want to check. Yes, something not right. Also, don't like this thing. Doesn't make any sense.
Responsible for ensuring that the length of the waveform list is at least equal to the width of the game screen width. If the waveform is shorter than the screen width, it will continue to generate and append new waveform segments until it fills the screen. The logic inside this loop checks if there are any remaining waveform data points from the last loop iteration in the remainder list. If there are, they get added to the waveform. If there is no remainder, it generates a new waveform segment. A random number, RND, is generated to determine if the new waveform segment should be normal or one of the abnormal types. The generated waveform segment is then added to the waveform list. If the generated segment is longer than what's needed to fill the screen, the extra points are stored in the remainder list for the next loop iteration.
Uh, so what if I comment? Right, so when I do this, yeah, we need to rewrite that whole logic. Let's do this, generate new. This generation business. Let's try that. That was the problem in the code. Would the bot pick up on move? Okay, can you rewrite this
Without
thing?
this segment, the waveform will not continuously replenish as it scrolls, eventually leaving an empty screen once the initial waveform data has scrolled off the left side. If you'd like to reintroduce the logic to generate new waveform segments or make other modifications, please let me know your requirements. Otherwise, the code you provided will initialize with a waveform, let it scroll to the left, and not generate new waveform segments.
Okay, I think this is a clear case of starting fresh, popping this.
Looks like you've provided a basic game setup using Pygame where the player is supposed to identify abnormal ECG, electrocardiogram, patterns. The game scrolls through the waveform, and the player tags the abnormal patterns. For every correct tag, they earn points, and for every mistake, they lose points. However, there are a few parts missing or incomplete in the code. You haven't defined how and when the abnormal waveforms are generated and added to the main waveform. The remainder variable is defined but not used. There's no logic for ending the game or presenting a game over screen.
Yeah, I have trouble with this remainder variable as well. Yeah, don't think we need remainder. We would like generate new waveforms as required. Mix in 50% normal and the rest abnormal, equally distributed among the 7 abnormal waveforms. This thing now, the previous game logic, I got rid of it. No, it's okay.
Alright, I see that you have a game using Pygame which seems to simulate the detection of abnormal ECG patterns on a scrolling ECG waveform. The primary mechanics of the game involve scrolling a waveform from right to left, allowing the player to tag abnormal ECG patterns, scoring the player based on their accuracy. However, there's a part of the code that seems to be missing or isn't. Half of these will be normal, and the other half will be divided amongst the abnormal waveforms. Here's how we can do this. First, we'll create a function to generate the new waveforms. Half of the new waveforms will be normal, using generate underscore full underscore waveform. The other half will be abnormal, divided equally among the 7 abnormal waveforms you provided.
Right, so we generated that function. It looks much neater. So we have, we need to pop it into the game. Go into the game logic, yes. That game. Yeah, we don't really need that loop, do we? Let's get rid of it. So we have one ECG scrolling on the window now. Now we need to generate the next. Let's get rid of that for a sec. We don't need it. Format. Oh, come on. Would it do refactoring or no? What did? Okay, let's bring it back. I'll keep it there for now. And we need this function.
Now, let's integrate this function into the game loop to append new waveform segments as needed.
It's making the same mistake as before. Which is pretty annoying.
This will keep the waveform and waveform underscore types lists filled with data as they scroll to the left, ensuring there's always a waveform to display. The game will then randomly show normal or one of the abnormal waveforms for the player to identify. You can integrate this logic into your existing game code. Would you like further assistance with anything else?
Yeah, integrating this and try doing it myself. Although that function should be here somewhere or not. All this need to be, yeah, moved that way. Got rid of the error, and we need to only have one game loop. Can it help integrating this? Can you generate the whole Python script on screen? I'll execute it locally without any placeholders or missing bits. Didn't get the second sentence, but that's okay because it's already doing it. Right, so that's that function. Yeah, it plays that one correctly, but yeah, we don't actually need this start game because this is only needed if you calling the start game from another Python script, which we might do later, but at the moment should have asked to remove it, but so that's the whole code. Yeah, can we ask it for a sec if we don't need? Do we need? Probably do not. See if it, well, it will suggest. Okay, it's generating it again. Just taking some time. Yeah, we have another Python script that actually generates all the functions, the different variations. So we have a 3 QRS variations of its shape, and another, what's it, 4 waveforms with missing bits in there. That would be the game, is to detect what's what. This one is not being called. It's the one that we replaced. Yeah, this seemed to be the whole thing. It's still under 100 lines of code. That's great. No binding 41. Should be a easy fix for this. This should be global instead of non-local. It's not local. It would be global. Right, so that's running now. Be mixing in abnormal. This is still normal. So that's 2 normal in a row. We actually don't like it. This is still normal. Okay, we have the same problem as before. This is abnormal. This scoring. What just happened? This one inverted. We had this problem before. Oh, come on, what's happening? So there are too many normal waveforms in the beginning. Is the mouse logic still in the code? Yeah, mouse button is still there. Drawing is obviously not. In the Python code, in Python terminal, we want to print out the current label type. The green circle labels are not appearing. The green circle labels are not appearing on the waveform anymore. The circle is there. Just pop it all in.
Else related to this game or any other topic. Alright, let's address these issues step by step. Too many normal waveforms at the beginning. This is because the initial waveform list is filled entirely with normal waveforms. We can change the initialization to include a mix of normal and abnormal waveforms. This is because the initial waveform list is filled entirely with normal waveforms. We can change the initialization to include a mix of normal and abnormal waveforms. Print out the current label type in the Python terminal. Whenever a new waveform segment is added, we can print its label type to the console. Green circle labels not appearing on the waveform. The logic for drawing the green circles is based on indexing the waveform list. Since you're scrolling the waveform and removing data from the start of the list, the indices of tagged positions will no longer match the waveform's indices after a few scrolls. We need to adjust the logic to ensure that the circles are drawn correctly. Let's address these issues in the code. Here's the updated code with the mentioned modifications. Python.
That's all the same. Yeah, we have this score print. We want to print current label. Yes, we do. Why is this so bloody hard? Yeah, we had it working okay. Cardio Quest. Yeah, this one was wrong. Can get. No, we'll leave it, but it's wrong. But again, two normal in a row. Three normal in a row. No, maybe we never had it working correctly. We just get back. The green circle label is in the beginning of the waveform instead of where the mouse was clicked. Can we also make sure we mix normal and abnormal waveforms from the beginning? We also need to make sure the type of the waveform corresponding to the current waveform displayed on screen. Right, so we got is the position of this screen circles. What on earth? Yeah, this position should be as before. Where the mouse is. What's up with that? It's wrong. That could be waveform generation. The other Python script being wrong. So that's abnormal. It's normal. Yeah, there's something wrong with that. Need to check the waveform generation as well.
Adjusted the calculation for the position of the green circle to account for the current scroll position. Use the generate _new _waveform _segment function to ensure a mix of normal and abnormal waveforms from the beginning. Printed the type of waveform being clicked onto the console. Regenerate. ChatGPT may produce inaccurate information about people, places, or facts. ChatGPT August 3rd version.
Right, so this is generating labels. So obviously for normal labels, I don't get any score. That's why the score is still 0. And this is abnormal because it's missing. Oop. Ba-ba. Ba-ba. Okay, let's try this again. Right, so the x-axis was corrected, so that's great. This is still normal because it has all the bits, so it looks like that. Yeah, this one is weird. It's abnormal. And we get this error. In line 87. Let's pop it, and that should be easy fix, I hope.
Code interpreter. 2/2. The part that generates new waveform segments. You mentioned. Apologize for the oversight. The error arises because the index, after adjusting for scrolling, is trying to access an element in the waveform list that no longer exists. Let's correct that by ensuring that we only attempt to draw circles for valid indices within the current waveform list. We'll adjust the logic that filters the tagged list to ensure all indices are valid for the current waveform. When drawing circles, we'll add a check to ensure the index is within bounds. Here's the corrected segment of the code.
So still need to make sure. So this, hopefully this will fix the issue while running. Buy game, quit. Can get rid of that. Was it abnormal? This is definitely abnormal. This is normal. Right, so I'm getting points down as expected. This one is normal so far. Yeah, it's normal. I'm getting 0 points. One normal again. Yeah, I don't want to have 2 normals in a row, things like that. But I do that. But I do want them 50% of the time, so a bit of another normal. Well, maybe not 3 in a row. But then I'm biasing the probability. Right, so this is abnormal. So the logic now is correct. And yes, if I get extra 50 points, it becomes faster. Yeah, this is abnormal because it's missing the T wave. It's also missing the T wave. This is abnormal because it's wrong. It shouldn't even be there. This is normal, abnormal. Normal points down, normal. Still normal. Yeah, probably. How come? It's 4 in a row. Yeah, then you have the subnormal, so this will go faster. Will go slower, faster. slower. I don't know. Okay, so there's a few. This is much better. This code is definitely a keeper. There's a few things. First of all, yeah, so this game logic is definitely a keeper. I wonder, how do I quickly just pop it onto GitHub? Test, summarize. If this is my, let's say I want to pop this on GitHub, whatever, keep its version. There's some GitHub options there, but that's not what I meant. Copy. Is it on GitHub already? I have to check. So my thing. Okay. Do I have them open? I don't think I have them open. Update. Wait. This isn't a specific. Right, this looks familiar. This video processing is yeah, I don't have it open at the moment. Okay, now I'm a bit confused. So this one, how about we get rid of it? Can we get rid of it? Okay, we'll leave it there. Know how to use source control. Confusing. Why is this grayed out? Because I can't commit to it. I only can commit to my own. That would kind of make sense. But if I have it forked, can I commit to my own GitHub? Don't understand. Anyway, we'll leave it for a sec. So we can publish it on GitHub in a bit. Get back to the game. First. Alright, this is still there, so it's fine. The abnormal ECG. Yeah, that's okay. That's normal. Abnormal. So I'm just testing again. Been testing it a lot. Would imagine this is abnormal. Why? Because it's missing something. It's missing the S wave. I can make more points for it to go faster. That was just wrong. I need to check. Still, and this is normal. This is working really well. and I shouldn't have marked it because the task is to mark abnormal ECG. This is normal again. Normal again. It seems like the numbers are skewed a bit. Right, this is abnormal. It's missing the P wave. So I can make some points. It will go faster. This normal. Getting points back down. Normal again. Okay, I know what we want to do. Yeah, this one just has a random choice. We probably later want to change this to like 40% chance, or even lower. Or as the game progresses, yeah, I want to make it harder. But first of all, we want to check that all the waveforms are plotted correctly. Um, can you create a function which stores all the different waveform types, including the normal one, into a file? So this will be an image file. This will be plots into an image file. Yeah, that's right.
Course. To achieve this, I'll use the matplotlib library to plot the waveforms and save them as an image file. Each waveform type, including the normal one, will be plotted in a separate subplot. Here's how we can do this. Import necessary libraries. Use matplotlib to create subplots for each waveform type. Plot each waveform in its respective subplot. Save the entire figure as an image file.
Yeah, let's do that. This will be in the same. Yeah, don't stop executing stuff on the server. Just give me the code. Yeah, that's the main reason why I decided not to pay for the GPT Plus anymore.
I apologize for the oversight. I attempted to execute the function without first defining the waveform generation functions you provided earlier. Let me correct that by defining the waveform generation functions and then running the plotting function.
Right, so it's trying to generate that all on the, so it's running the whole script on the server. That's why it takes so long. No, it's still writing the code and then it's executing it. That shouldn't take too long, but it's doing all that on the Open AI server. It didn't show me the image. Right, so that's What's up with that? Yeah, the QRS variations are wrong. Um, the QRS variation should still have all the other components. Okay, we had it working okay before. Just pop it on another screen. Yeah, we have this code as well that just plots plots everything. I'm pretty sure I checked that it was correct, but I didn't actually overlay it that way. Can you change the plotting to not be overlaid? Plot all the waveforms vertically, one on top of another. Also, save the figure into PNG file that is located in the same folder where the Python script is run. It's just another code. Yes, subplot arranged vertically. Um, Again, don't run. Don't, don't run. Look, just give me the code. Okay, it did give me the code. Try it. No, this bit is not right because this is saving in the wrong place. Yeah, don't see the image. The image is not there, which is a bit odd. Right, those are the actual images. They are better. Yeah, this one doesn't have the variation 3, 2, 1. No P wave, no Q wave. This looks like normal to me. Alright, no S wave, no Q wave. No P wave, that's correct. No Q wave seems to be wrong. No T wave is correct. No S wave is correct. Yeah, no Q wave is wrong. Should we get rid of it or try and fix this? Be able to save this. Where's the code? Yes, it's running. I keep asking it not to run things on the server, but it still does. But we do see a mistake. So no Q wave. Looks like the normal. No Q. Looks like the normal waveform. Let's address this first. This thing need to be. Oh, come on, waveforms. Yeah, I'll save that.
Code interpreter. Let's break down the issue. The function generate underscore full underscore waveform uses the refined underscore r underscore wave function by default for the QRS complex, unless a QRS underscore variation underscore function is provided. When using the no underscore q underscore wave function as a QRS underscore variation underscore function, the no underscore q underscore wave function essentially defaults to the refined underscore r underscore wave for the majority of its range. This makes the waveform look almost like the normal waveform since there isn't a significant deviation from the usual QRS complex. To correct this, we need to define a specific behavior for the Q wave section in the no underscore q underscore wave function.
Yeah, this thing, I didn't have it happening a while. It's a problem in the browser. Where the text to speech will get stuck. Right, the no Q wave. ECG Wave. There's actually no Q wave. Which part is? Yeah, forgot the Q wave. Uh, no, it's doing something on the server. No, actually, what it does. Can save this. So now instead of waveform generation, we call waveforms. Okay, now this code. Let's see if it picks up on any issues, because it's actually giving me an error when trying to execute. It's thinking about something. One of the functions is missing. Generate multiple waveforms. I think I can get rid of it. I don't think it didn't pick up on any errors. That's normal. Two normals in a row, that's okay, because we have 50-50. Three normals in a row. Yeah, this abnormal. Know what's abnormal about it. This is normal, so it's the abnormal. Yeah, so I have a few more problem. The logic is there. Which one is just a flat line? One is a flat line and one just looks like the normal. That's the Q wave one. Yeah. We could get rid of it. The Q wave. Which one we getting rid of? No. Q wave. This is normal. Yeah, later we want to be able to change the ratio. So currently it will be 50% normal ECG. Should look like that. Yeah, we're still missing the Q wave there. Right, this is abnormal. Let's see if it's actually correct. It has the B, has the R, it doesn't have the S. So no S. It's correct, that's normal. So I'm getting points reduced, normal, points reduced, normal. Right, this one's still there. Why? Yeah, I want to check what's that flat line. Not meant to be there. We adding zeros or something somewhere? Anyway, it's too fast now, too hard. At least for me, if anyone can. If anyone can keep up with it, get a lot of points. We will later add a leaderboard so you can compete. Hopefully come back to my website. Yes, there will be some ads. Sorry for that. But currently there is a flat waveform. Where is it coming from? It's still in the game logic. And why? Yeah, I'll start a new chat because text to speech stopped working. So GPT-4 code interpreter. Is there any zero padding? Yeah, I'll just start menu. Oh, come on. See what it says. What? Why is this still not working? Yeah, I might just continue next time. Probably, hopefully later today. If not, next week. And I'll try popping this on GitHub as well. I don't know, questions or comments in the chat. I'll talk to you in a bit. Bye.